In this example, I need to find all solutions of the equation sine theta equals 0.8142 in the interval 0 degrees to 360 degrees. I also need to round the answers to the nearest tenth of a degree. So we know I'm looking for angles in degrees, and since it said to round the answer, I'm most probably going to have to use a calculator. And looking at the value for the sine of theta, this is not a value on the unit circle, so this confirms the fact that I'm going to have to use a calculator. So I need to take the inverse sine function of both sides of this equation. So I have the inverse sine of the sine of theta equals the inverse sine of 0.8142. Now on the left-hand side, what's the inverse sine of the sine of theta? That's just theta. So theta is the inverse sine of 0.8142. So now I need my calculator. Here is my calculator. It's a TI 84 Plus. The first thing I need to do is make sure I'm in degrees. So look at the mode. Currently, radians is highlighted, so I need to scroll down over, hit enter. Now degrees is highlighted, so I need to quit, so hit second mode. So now I'm in degrees, I just need to type this in. The inverse sine function is in blue above the sine key, so I'm going to have to hit second sine. That gave me the inverse sine function. And now I need to put my value in of 0.8142. Close parentheses and hit enter. And here is one of my solutions, 54.508, etc. degrees. I need to round it to the nearest tenth of a degree. That's the position of the 5. The 0 is not going to change the 5. So my answer is theta equals 54.5 degrees. Now that is one solution to this equation. Now how many solutions does this equation have? In fact, it has an infinite number of solutions, but I only need the solutions in the given interval. How many solutions did the calculator give me? It just gave me one solution. And why did it do that? Remember, the inverse sine function will only give you one answer, and that answer has to lie somewhere in the interval of negative pi over 2 to pi over 2, or in this case, negative 90 to positive 90. As the sine of theta, by definition, equals y over r is always positive, so the sine of theta is going to be a positive number when y is positive. Well, is y positive in quadrant 1 up here or down in quadrant 4? Y is positive up here in quadrant 1. So that is why the calculator gave me an angle up here in quadrant 1. There is my angle theta of 54.5 degrees. Now all we have to do is figure out, is there another quadrant in which the sine of theta could be positive 0.8142? Well, the y value is also positive here in quadrant 2. So I need to find a solution in quadrant 2. And to do that, I'm going to use reference angles. So let me quickly draw my angle in quadrant 2 that I'm looking for. And remember, the reference angle is the acute angle the terminal side makes with the x-axis. So here is my reference angle, theta prime. And the reference angle for the angle in quadrant 2 has to equal the reference angle for the angle in quadrant 1. And what is the reference angle for the angle in quadrant 1? Well, remember, in quadrant 1, an angle is equal to its reference angle. So I know my reference angle for both of these angles has to be 54.5 degrees. So I'm trying to find my second solution. I'm going to write it as theta sub 2. So how am I going to find my second solution, theta 2? Well, theta 2 plus theta prime has to add up to 180. So my second solution is just 180 minus theta prime of 54.5 degrees. And what is that? Well, if I do 180 minus 54.5 degrees, I get 125.5 degrees. So that is the second solution in my given interval. And one last thing we can do is we can check to see if we did this correctly by just finding the sine of that angle. So what is the sine of 125.5 degrees? Is this the same as what we started with? It's approximately the same, but remember I rounded this answer, so this is going to be approximately the same as this. But this is a good confirmation that you did the problem correctly.